Hello friends, welcome in compiler designing class. In today video session, we will discuss what are the different type of parser and how they are categorized. So, as you know that parser is nothing but it is a syntax analyzer and it will accept a stream of tokens and based on some grammar, that is you can say context free grammar, based on a context free grammar using these tokens, parser generates a parse tree. So parser is also called syntax analyzer. So in this session we will discuss that what are the different type of parser and how they are different from each other. So as you can see, basically there are two type of parser: top down parser and bottom up parser. And top down parser, we will discuss later on that what is the difference between top down and bottom up parser. Just as a classification, I can say that top down parser is further divided into two parts. One is called a top down parser with full backtracking, and another one is called a top down parser without backtracking. Now the meaning is backtracking is something like this, that if you want to generate a string and you start from a root or starting symbol and you just make some expression like this, and the parse tree is generated, and suppose if you did not get the desired result, then you can backtrack and you can restart with some other options. So in top down parser we can use go with full backtracking, and it is nothing but a brute force method. And if it is a without backtracking, means when we start building up our tree, so we have to decide which production I should use to get the desired result. There is no chance to go backtrack. So this is the difference between full backtracking or without backtracking. And the without backtracking parsers are again divided into two parts. One is called recursive descent parser and another one is called non-recursive descent. And why they are called recursive or non-recursive? So in recursive descent, basically the parser use recursive function, that's why they are called recursive. And this non-recursive descent parser is also called LL1 parser. We will discuss all these parsers in our coming videos. So you can say the non-recursive descent or you can say LL1 parser. So both are same. Similarly, your bottom-up parser is also called SR parser, where S stand for shift and R stand for reduce. So we will see how the shift reduce parser work. So basically they see in bottom up parser we will use a stack, and when you are pushing an element into the stack, that is called shift, and when you pop something from a stack, that is called reduce. So in bottom up parser we will use some shift or reduce operation, that is push and pop operation. Again, the bottom up parser is divided into two parts: operator precedence parser and LR parser. LR parser is again of four type: LR0, SLR0, LALR1 and CLR1. So we will discuss all these parsers one by one. And one more thing is there, that all the parsers, they should not they don't support ambiguous grammar. So the parser do not support ambiguous grammar. And your top down parser, they do not support left recursion, they do not support non-deterministic grammar. So we have to keep in mind that whenever we are going to use a top down parser, it should not be the grammar should not be ambiguous, the grammar should not be left recursive, and the grammar should not be non-deterministic. So we have to keep it in mind. But one more thing is there, that operator precedence parser, it support ambiguous grammar. So we will discuss how, but at this moment of time you can just make a point that operator precedence parser support ambiguous grammar, but except this parser, all other parser they do not support ambiguous grammar. Top-down parser do not support left recursion, they do not support uh, non-deterministic grammar. Now we will see that what is the difference between basic difference between top-down parser and bottom-up parser. There are two type of parser, top-down parser and bottom-up parser. So first we will discuss how the top-down parser works. So what are the basic properties or characteristics of a top-down parser with one example. So just assume that we have given a grammar is having these production rules. S derive A, capital A, B, E, A derive A, B, C, and B derive D. And suppose this is my given string A, B, B, C, and D. So first of all, that top-down parser always start from root to leaves. Okay, so in top-down parser, you will be given a grammar and there will be a string that we have to generate using these production rules. And in top-down parser, we start from top. Top means we will start from root and we will move toward bottom. So first difference is in top-down parser, start from root and go to leaves. Second thing is that if some productions are given, then according to your string, we have to decide which production I should use to get this desired string. So we will see this. So S is the starting symbol. So at this level you don't have any choice. So you have to start with S generate A, capital A, B, and E. So I'm using production number 1 at this level of time. So we have to decide that to achieve this string, which production I should use. So I have chosen production number 1, S derive A, B, and E. Now second thing is, now we need A, so we got the A. Now again we have to think that which production now I can use to get this desired string. So I can use production this one, A generate A, B, and C. So here I am using okay, I can number it 1, 2, 3, and 4. So I am using production number 2 over here. So this is okay. Now according to the required string, again you have to decide that which production I should use. So I am using here it is A generate B, and this B generate D. So here it is production number 3 and here it is production number 4. So now if you scan this from left to right, you will get A, you get B, then this B, then this C, then this D, and E. So you got the desired string. So idea is that you start from root, decide a particular production according to your string, and move downward, means from root to leaves, and you will obtain the desired string. Second thing is that if you can observe that this top-down parser uses leftmost derivation. So let's see how it will be. So S generate A, B, E. Now again you can scan from left to right. This is terminal, it is okay. Now instead of this A, what you have written, A, B, C. So you have expand A, B, C, B, E, and then if you see, you have used production number 3. So if you go from left to right, A is okay. Then instead of this A, you have used B, B, C, B, and in the last one you said you A, B, B, C, D, E. So basically you have used a leftmost derivation, and what the leftmost derivation says that from left move to right and expand each and every non-terminal according to your requirement. So this is the basics of top-down parser. That top-down parser uses leftmost derivation. It starts from top, that is root, and it moves to leaves, that is bottom. And in this production we have to decide which production I should use. We have to choose which production to get the desired string. Now the bottom up parser says that we should start from leaves and we should move to root. What does it mean? If this is a string, so what we will do is A, B, B, C, D, E, and then we have to think about which production I should use to reduce this leaves into some root, and we have to move from bottom to top. It means we have to move from leaves to root. For example, I can say that this B can be reduced to A using this production. B is generated by A, so I am using production number 3. Then this A, capital A, this small b, and this C, these 3 can be reduced to capital A. Which production we have used for this reduction is production number 2. Now we can say this D can be reduced to B. Which production I have used? Production number 4. And finally this A, this B, this A, and this A, and finally we got S. So as you can see that we started from leaves and we move upward to the root, and so we can say that we got the string. So this is your bottom up parser. This is your bottom up parser, and here we have to decide that which production is used to reduce. For example, see, this small b is reduced to A, then this capital A, small b, and C, these 3 are reduced to this capital A, then this D is reduced to capital B, and finally small a, capital A, capital B, and this E is reduced to S. So this is how the bottom up parser work. Second thing is that if you just take this like this, if I am going to do the derivation process, so it will be like this: A, B, E. Now this is S, A, B, E. Now this derivation is from right side, so E is okay. Then instead of this B, we have written this D, and rest of the things are same. Now again we have to scan from right to left. E is okay, D is okay. Instead of this E, A, we have A, B, C, and this is our string. And then again we scan from right to left, E, D, C, B, and then this B is reduced with A, or like this. So we got the string. So idea is that bottom up parser, they follow the rightmost derivation. just remember. And since we move from bottom to top, that's why you can say that the bottom up parser use rightmost derivation in reverse order. Rightmost derivation in reverse order. So this is what we have, uh, the two different type of parser, top down parser and bottom up parser. So thank you very much.